Hello everyone, welcome to chemistry sharing. So guys, as you already know that these days we are doing atomic structure chapter, and in the last class we have seen what is electromagnetic radiations, how are they produced. Also we have discussed about various properties of electromagnetic radiation. So based on those topics, let's practice some problems. Okay, so the very first question is, the wavelength of violet light is 400 nanometer. Calculates its frequency and wave number. So how you are going to solve this problem? Just try once. See guys, if you have seen the last video, then you must be knowing the relationship between velocity, frequency and wavelength. So that relationship we are going to use here. Okay, so we know that velocity is equals to frequency into wavelength. That means frequency will be equals to velocity by wavelength. Now we know that all the electromagnetic radiations travel with the same speed of velocity, that is 3 into 10 to the power 8 meter per second. Okay, and light is also an electromagnetic wave. Okay, so it will also have speed of 3 into 10 to the power 8 meter per second. The value of wavelength is given to you, that is 400 nanometers. Now we have to convert this nanometer unit into meter unit, because whenever you solve numerical type question, then always keep in mind that all the terms should have same units. Okay, now 400 nanometer will be equal to 400 into 10 to the power minus 9 meters, because we know that 1 nanometer is equals to 10 to the power minus 9 meters, isn't it? Now putting the values of velocity and wavelength, we can easily find the value of frequency. So see how we can find it. So we are getting 3 by 400 into 10 to the power 17 per second. Now how are we getting 10 to the power 17? Because we know that whenever any number having power is present in the denominator is taken up in the numerator, then its sign changes, isn't it? Previously we were having 10 to the power 8 in the numerator and 10 to the power minus 9 in the denominator. So when we take that 10 to the power minus 9 from denominator into numerator, then its sign changes and become 10 to the power 9, and we know that the powers are added, so 10 to the power 8 plus 10 to the power 9 is equals to 10 to the power 17. Okay, then see the next step. We are converting 3 into 3000 so that it becomes easier to divide 3000 by 400. Okay, and since we are multiplying 10 to the power 3 into 3, that's why 10 to the power 17 is becoming 10 to the power 14. Okay, so this is very basic mathematics and you should know this. Okay guys, and finally we are getting the answer to be 7.5 into 10 to the power 14 per second. Okay, now see the next part, how we can calculate the wave number. We know that wave number is equals to 1 by wavelength, that is nu bar is equals to 1 by lambda, and the value of lambda is given to you. So after putting the value of lambda and solving it, we are getting the value of wave number to be 25 into 10 to the power 5 per meter. Okay, then see the next question. The frequency of strong yellow line in the spectrum of sodium is 5.09 into 10 to the power 14 per second. Calculate the wavelength of light in nanometers. So again we will use the same expression for solving this problem, that is velocity is equals to frequency into wavelength, that is c is equals to nu lambda. So lambda is equals to c by nu, and c, that is velocity, we know it is 3 into 10 to the power 8 meter per second, and the value of frequency nu is given to you, that is 5.09 into 10 to the power 14 per second. So by putting the value of c and nu, we can easily find the value of lambda. We are getting the value of lambda to be 589 into 10 to the power minus 9 meter. But since in the question it has been asked to find the value of wavelength in nanometer, so you have to convert this meter into nanometer. So on converting, we are getting the value of wavelength lambda to be 589 nanometers. Okay, Then question number 3, the wave number of a beam of light is 400 per centimeter. What is the wavelength of light in nanometer? Also find out the frequency of the light. Okay. Again, you have to do the same thing. First of all, you have to identify what is given to you and then which formula you have to apply. So your wave number, that is nu bar, is given to you, which is 400 per centimeter, and we know that nu bar is equals to 1 by lambda. So by using this, we can easily calculate the value of lambda. So lambda is equals to 1 by 400 per centimeter, which is equals to 2.5 into 10 to the power minus 3 centimeters. Okay, but since you have to find the answer in nanometers, so convert centimeter into nanometer. How you can convert it? By multiplying it with 10 to the power 7. Why? Because 1 nanometer is equals to 10 to the power minus 7 centimeter. Guys, how I'm telling that 1 nanometer is equals to 10 to the power minus 7 centimeter or 10 to the power minus 9 meters or not? Because in the last video I have taught you all the unit conversions. So if you want to watch that, do watch the video. Link you can find in the description. Okay guys, so finally we are getting the value of lambda to be 2.5 into 10 to the power 4 nanometer. Now to calculate frequency, we know nu is equals to c by lambda, or nu is equals to c into nu bar. Now the values of c and nu bar are given to you, so just put them and solve it and you will get the answer 1.2 into 10 to the power 13 per second. So in this way we have calculated the values of lambda and nu both. Now let's see the next question. A radio station is broadcasting programs at 100 megahertz frequency. If the distance between the radio station and the receiver set is 300 kilometer, how long would it take the signal to reach the set from the radio station? Also calculate wavelength and wave number of these radio waves. So this is quite interesting question, isn't it guys? So let's see how we can solve this. First of all, we have to see what all things are given to us. See, the frequency is been given and the distance has been given, and we have to find the time, wavelength and wave number. Okay, so we know that the electromagnetic waves has speed of 3 into 10 to the power 8 meter per second, and radio waves are also electromagnetic waves. They will also have same speed. Now we know that time is equals to distance by speed, and distance is given 300 kilometers. So we can write this as 300 into 1000 meters. Divide by 3 into 10 to the power 8 meter per second, and on solving this we are getting the time to be 1 into 10 to the power minus 3 seconds. Then to find the wavelength, we know that c is equals to nu lambda, or lambda is equals to c by nu. Now the values of c and nu are given, which is 3 into 10 to the power 8 meter per second, and nu is 100 megahertz. Now 1 megahertz is equals to 10 to the power 6 hertz, and 1 hertz is equals to per second. That means 100 megahertz is equals to 100 into 10 to the power 6 hertz, and it is also equal to 100 into 10 to the power 6 per second. Okay, and on putting the values, we are getting the wavelength to be 3 meters. And wave number nu bar is equals to 1 by lambda, so it is 1 by 3 meters, that is 0.33 per meter. Okay, then coming to the last question, calculate the wavelength, frequency and wave number of a light whose period is 2.0 into 10 to the power minus 10 seconds. So to solve this question, let me tell you guys that frequency of wave is inverse of period. Okay, that means nu is equals to 1 by period, which is 1 by 2.0 into 10 to the power minus 10 second, and it is coming out to be 5 into 10 to the power 9 per second. Now c is equals to nu lambda, so by putting the values of c and nu, and solving we are getting lambda to be 6 into 10 to the power minus 2 meters, and for wave number it is 1 by lambda, which is equals to 1 by 6 into 10 to the power minus 2 meter, that is equals to 16.66 per meter. So that's all in this video, friends. I hope you find this video helpful. So please like the video, share among your friends, and if you have any kind of queries, then let me know in the comment section. Okay guys, so thank you so much for giving your precious time to my video. Thank you.